everyday examples. First, we have compass. We talked about that a little bit in the last video, 10.1b. Compass is something everybody's seen, everybody's familiar with. It works because the ferrous material, or the needle, is attracted to north and south poles, so therefore it turns. Next, we have cathode ray tools. Cathode rays, well, when there used to be tube TVs, this is what helped us have TV, but it also helped us develop and understand the charge to mass ratio of electrons. So it helped us figure out how much electrons weigh based on charges, which is pretty cool. Next, we have data storage. Now, I know you guys are like, well, who cares? It's data storage. You know what? Here's the deal. Your driver's license and any type of credit cards that you have, that strip on the back, that is your magnetic storage. All that magnetic strip has in it is all the information that you have on there. So that's why it's easy to destroy it. If you were to rub it with a magnet, set it on top of a speaker, because speakers have magnets, you can actually destroy the data stored on that magnetic strip. Now, the next four things, the northern lights, the magnetic resonance imaging, or MRI, which is a medical tool, the magnetic trains and mass spectrometry. I actually have videos for that. So the short videos, it gives you an idea of how they work and why we need them. And then at the end, kind of think about, well, what else can you think of that might use electromagnetism that you use in everyday life? Okay? Great. Enjoy the videos.
Perhaps you've seen these videos online. Some especially stunning aurora have been dazzling YouTube viewers these past 2 weeks. It's as if space is painting us a beautiful picture. Or just showing off. We talked to our resident space expert, Dr. Ian O'Neill, to find out how these are created, where you can find them, and why now.
Basically, the sun's surface is currently going through quite a lot of magnetic activity because we're approaching solar maximum, which is part of the 11-year cycle. Very natural cycle, there's nothing scary about it, and we're approaching the maximum activity, and that's going to happen in about 2013.
The sun's kicked into high gear, causing enormous eruptions of solar wind and plasma that are aimed right at us.
It impacted our magnetosphere. That's the magnetic shield that surrounds our entire planet. Now, if the conditions are right, and when this magnetic bubble, this coronal mass ejection, hits our magnetosphere in a certain way, it can inject solar plasma into our magnetosphere, and that funnels into the polar regions. And when these plasma, these are basically mainly protons, high energy protons, when they hit our atmosphere, they generate light. And when each one hits, you get this fantastic aurora.
These aurora are being seen in northern latitudes, like in Sweden, and near southern latitudes, like in New Zealand.
Sie sehen欢迎来到马普协会。
Here in Germany, engineers are testing an experimental train that all but eliminates track friction. Because the train doesn't ride on tracks. This train literally floats on a magnetic field. It's called maglev, for magnetic levitation.
Maglev technology is doing what a typical train does, except using electromagnets. Instead of having wheels and rails, we have magnets to lift and guide the vehicle, and then a non-contact propulsion system to propel the vehicle down the track.
With a powerful enough magnet, literally anything on Earth will levitate. A drop of water, an ice cube, even a strawberry. maglev trains work like this. When the system is first powered on, a powerful electromagnetic field lifts the train up, about an inch off the track. Powerful generators in the track then begin to produce waves of magnetic energy, which propel the train forward. Because the train never makes physical contact with the guideway, there's no friction. And that makes the train very fast. The current model is designed to go as fast as 310 miles per hour, but the technology can potentially go much faster.
What happens if you have something like this, and you want to find out if something like this is inside? Obviously you can't tell just by looking at it, but if you separate things out, the answer becomes clear. Scientists have the same problem. How do you know if there was once water on Mars? Or, for that matter, life? Obviously you can't tell just by looking at pictures of Mars, but scientists think the answer may lie hidden in tiny molecules in Martian soil. So, how do you take apart a molecule to see what's inside? Luckily, scientists have a tool to do just that. It's called a mass spectrometer, and it lets us take an extremely close look at whatever we're studying. And even though Mars immediately comes to mind, mass spectrometers are used in multiple NASA missions. They're also used in labs for hundreds of scientific purposes. But the important question is, how does it work? Today we'll be looking at a special kind of spectrometer called the quadrupole mass spectrometer. It's called this because of the 4 long poles that make up the center of the instrument. So say you have a sample that's been turned into a gas, and you want to find out if it contains certain things. The gas is sent into the mass spectrometer, first hitting a piece called the ion source. Here, a stream of electrons hits the molecule, breaking it into fragments and giving each fragment a charge. Next, the fragments enter what's called the analyzer. Here, they're separated based on their mass, and the analyzer is tuned so that only the fragments we want to see make it all the way through. Everything else flies off in a different direction. After this, the fragments hit what's called the detector, and scientists record the data. If you're looking for more than one kind, the analyzer can scan across a range of fragments, building up a record of not only what kind, but how many. Once you have these results, called a mass spectrum, you can verify that your sample in fact contains what you're looking for. And here, the real work begins. The mass spectrometer is a powerful tool, and by taking many samples, looking at the results, and studying what we find, scientists can work to discover not only the secrets of water and life on Mars, but also answers to bigger questions about the universe. And all by studying something as tiny as a molecule.